Good morning. Wow, this is a really neat sight to see. This is a popular room. That must mean that everyone here is writing developer tests when you write your code. Is that what this means? I sure hope so. This gentleman over here to my right, your left, is Peter Provost. He's responsible for many of the super hippie Agilista tools that we're finding in Visual Studio these days, and therefore my hero.
Super hippie?
Yeah, big time.
That's why you picked this picture of me.
Well, that's one reason. The other one is I found it.
Oh, okay. And this is David Starr. David Starr is the software craftsman with Scrum.org. He is one of our ALM MVPs, Elegant Code founder, speaker, writer, and a good friend of mine.
And I just thought I would mention, because it amuses both of us, that my daughter thinks we both look like this guy. Okay.
I've shortened it up a bit.
Yeah, you have, and that's good. Here's what we're going to be talking a bit about today. We've got several scenarios that we want to walk through because we've talked to a lot of developers out there in the world about what are the things that are really ugly for you, what hurts. And we certainly don't want testing to have to hurt for developers, because when something hurts, we don't do it. And so some of the things that we'll see may not be beautiful, to be honest, but there are ways around some of these painful situations. Here's what you're not going to hear today. You're not going to hear that here's a tool that will save your life. Sorry. You're not going to hear that poorly designed software just became no problem to test. Not going to get that either. And you're not going to get, see, it's fun and easy to put an existing big ball of mud under a big test regression harness.
Because it's just not. It is certainly the case that we're doing everything we can to create tooling to make testing easier, or even just possible. But it is always going to come down to the design of the code. And so we'll be talking a bit about design and how design impacts that as well. So when we're talking about design of software, of course, one of the things that is kind of a dominant characteristic of our software designs are the dependencies we have. Dependencies between classes, between methods, assemblies, layers, namespaces, components, controls, services, you name it. And sometimes these dependencies are kind of forced upon us by code that we either consume or frameworks that we live within. So if you take a look here, we're looking at the .NET Framework 3.5 version of this context class. This is the execution environment of an activity in a workflow. Anybody work with workflows at all? Right? We were just talking with Chris Patterson from Team, who's on the Team Build. And of course, they use workflows in Team Build, and we were asking him interesting questions about that. So here we have, the activity. And just if you take a look at this class, it's sealed. And, sure, it has an interface that it implements, but service provider probably isn't really the interface that represents what an activity is. So as we get around to thinking about how we might use this class, or how we might test a class that derives from this, we're going to have issues. Well, first of all, we can't derive from it, right, because it's sealed. But, of course, our own activity is going to consume one of these. So what do we do? How do we deal with that? If we take a look then at what they did when they moved to the next version, look at that. It's not sealed, which means we can inherit from it. That could be useful when we get around to testing it. It's not about, it doesn't have all of these other extra things that it claims to be doing, right? If we see an iDisposable, we know that it has got resources it needs to free, and you need to be responsible for freeing them. Well, does an activity context always have the resources, or maybe, or sort of, and questions like that. And you can see now we have a bit of a hierarchy of them. There's different kinds of activity contexts, but now we have some control over what we want to do with it.
I think we've seen a general change in the .NET Framework versions themselves to produce APIs that are simply better to be consumed by us, if you think about us as the customers. And so what we want to encourage you to do today is that if you make APIs for others, to look at some of the decisions that have been made in the .NET Framework itself, like this. Designing for testability results in a better design, in this case. Take that home and think about it and how you're impacting your customers with your APIs.
Well, and remember, the APIs that you're producing inside of your code, perhaps you're writing a piece of code that serves a bank, the lending business, or even a website. And so you probably start by thinking, the customer of this code is that customer. It's a banking customer. It's a website user. But when you're building a layer or a component or a piece of code inside, the customers of that code are the other people on your team, the other people inside of your organization who are going to be consuming that code. And so if you don't think about that piece of code as if it were an API that has the same kind of design thought put into it that this is demonstrating the evolution of, right? You want to be putting those same kinds of thoughts on your own APIs when you're putting them together, because there are lots of different kinds of customers. So
let's look at a gnarly way to have to deal with this.
Nope. See, I noted that way. No, you just turned me off. See, push the red button.
There we are.
There we go. So what we have here is a classic, old school ASPX website. Okay? And lots of us are still having to deal with ASPX websites. We probably have seen and heard of, or even wish we could use MVC and Razor and all these other frameworks that are available to us that are better for testing and more decoupled. But if you look back in time, and we go back, of course, these ASPX pages were huge, dominant. And it turns out that you actually could, if you were very careful, start to think a little bit about testability when you were building pages like this. So here I have a simple ASPX page that has 2 labels and a button. And if I show you what this looks like in kind of preview mode, what's going to happen is we're going to click the button. The button's going to do some work, and it's going to populate the 2 labels. How would you test this? Okay. Well, if we had not done anything special, what we would probably end up with is we would have double-clicked on that button. Right? In the classic mode, we would have just gone and double-clicked on that button, and we would have started typing code into this click handler. Now, what I've done instead is I've introduced a pattern called the model view presenter. So instead, you'll notice there isn't really very much code here. Instead, it defers that off to the presenter. So I don't really have to think about testing this guy. Instead, I can now test the presenter. And why do I need to do this? I need to do this because of this class right here in the inheritance hierarchy, page. Page is notoriously difficult to deal with because it comes from the old school IIS ASPX world, and it has wonderful things in it like HTTP context. Has anybody here ever tried to test near HTTP context? Yeah, fun. You can, in fact. And even though I've introduced the presenter layer here, I'm still going to depend on HTTP context, and let me show you why. If you recall what this page looks like on the screen, it's going to show the host name and the IP address of the server. And where does that information live in an ASP.NET site? It lives in the request object of the HTTP context. So we're still going to have to get there. Let's take a look at how we do it. So I thought I was doing a good thing here, right? I introduced this presenter. I isolated myself out, but I'm still going to get stuck. If we go take a look at get data now. So get data reaches out into the HTTP context, reaches then into current, the static property on it, reaches then into the request object, reaches then into the server variables collection, pulls out the 2 values that I want, creates an instance of the model, returns it back, or passes it then into the view. And in MVP, we typically will do this, where the view is responsible for translating in and out of those. It's similar to MVC and similar to MVVM. These patterns are all very similar. We'll talk more about that in a bit. So what I want to test is this method right here. This is the method that's doing our logic, and I still have this context. So I had made some advantages by separating, because now it's easier for me to new up the object, but because of the logic within, I'm still in a tight place. Of course, in the ideal world, I would extract this out. I would move this somewhere else. But if I didn't, what would I do to test this? So if we take a look at my first test, this is probably our most obvious, naive example of how we might test this. So I have a stub or a mock of that view interface. So this is the part where I was planning for MVP. And I created one of those. That's this line here. And I passed it into the presenter. Excellent. I asked the presenter to do something, and then I go back and check the model that it passed back to the view. Except, of course, there is not going to be an HTTP context. Let's run the tests and take a look at what happens. So our test fails because we're getting object reference not set to an instance of an object. And if we go and take a look, where are we getting it? Right here where we expected, HTTP context.current. Current is empty. So I'm stuck right here. And I'm still 2 or 3 dots from the end of the sentence. Right? We've all heard of the law of Demeter, right? Only talk to your friends, not to your friends' friends. This guy has a lot of friends. So I'm going to have to make this go away. What are my choices? Well, they're not pleasant. Of course, the first one is I could refactor that stuff out. But assuming that for some reason I can't do that, what we're going to do is we're going to take advantage of shims in Visual Studio to allow me to take over that HTTP request. And let me now uncomment this next test, and we'll take a look at that one. Okay, so this is a long test, unfortunately, so let me get some of these screens out of the way and we can take a look at it. So what do I have to do here? Well, I did the same thing before. I created a model. I created a stub of that view, so the mock of that view, which collects that model. So far we're the same as the naive test. But then I have to make the request go away. I have to make the context and the request go away. So I have to use shimming. And shimming is like, similar products are like Type Mock and Telerix Just Mock, and now we have shims in Visual Studio Ultimate. These are all in the same way. They let you take over anything you want in .NET, replace it with something else for unit testing purposes. So here I'm taking over HTTP request, and I say when they ask for the server variables, return them this collection, which has my make-believe, made-up test values in it. But of course, it was 2 or 3 dots away, so then I have to stick that one inside of somebody else, the context. And all of these are sealed classes. All of these are inaccessible. There's no interfaces. There's no friendly substitution points for you to go in and say, don't use that one, use this one. So we have to use this ugly construct of shimming, taking over and detouring. And when I do that, then I can go back to the way the other test was. Get data, assert the values. If we take a look at this test now we're able to get it to pass. So this is a little bit about your own API design, plan for testability, think about your testability. And I did well when I thought about Model View Presenter in this case. But I didn't continue. I stopped because I thought my only customer was that one. I didn't think about other customers like my tests. My tests are a customer of this code. And so I still was in a bad place where my tests couldn't handle this because of this HTTP context. And the context is really the problem class here. It's sealed. You can't replace it. You can't get in the way of it. You can't do anything you need to do to test near this class. And when we were looking at the workflow example just a second ago on the slides, we saw the same problem. It was a sealed class, and then when you're dealing with your activities, you're stuck. You can't get rid of it. So be very careful about these context classes. Let's go back over to...
No, you're going to go to MVC, right?
Yes. Okay, so the other one I wanted to show you then is if I do this in MVC. So I'm using ASP.NET MVC now, and it's going to be the same code. But I do it now using MVC. Model View Controller, ASP.NET has now created that MVP separation for me, but now all of the other parts that we care about have been also abstracted. There isn't the same context class that we had in ASP.NET. It's much easier to get into and replace. So the class that does the work is very similar. get it from request.server variables and put it into the view. But if we take a look at how I'm able to test this now, I'm now able to use plain stubs, plain mocks, because HTTP request base and HTTP context base are nice, overridable abstract classes instead of being sealed. They're very much like interfaces. Very easy to replace, and I'm able then to replace the request with the same value set, the context that returns that same request, stick it in the controller, and validate the results. So as you can see, the test is simpler. It also runs a lot faster, and everything is nicely decoupled. So this is, again, where the APIs at Microsoft have evolved in support of this testability, and you should also be thinking about that as you're heading towards your own APIs.
So help me understand that. Wrap that up. The lesson is, if I've got this one API that I was able to solve a problem this way, and it was really kind of hairy for me to do that as a developer. Similar API,
Similar.
Web development over here, solve the same problem in a new way. What was the real difference in between those two solutions?
So the primary difference between these is really the classes that we're depending upon. So here our controller is depending on these request and context base, these abstract classes that are very easy to replace and override, as opposed to depending on sealed, lockdown, unreplaceable, unmockable objects that we then have to use cheater hacks and detours to get around.
Cool. All right. Well, we're not always testing right under the skin. Sometimes we test in different layers of our application. And I had an opportunity to work with a really great team that for a long time had a test manager who would say the following to me quite often. Let's see here. He would say this: I can only know that everything in the stack is working if we're actually touching the UI when we do the testing. Who in here feels like Scott? There are going to be some. Yeah, there are some people out there. And it's a hard argument to deal with. It's kind of logical that there's really not much, there's not a lot to refute this. So we come up with ways to say, oh, we could do right under the skin, right under the glass, however you want to call it, and we come up with all these fancy patterns and ways to do it. However, the truth is, Scott's kind of right, because when we build a test like this and a developer taps it in to say this layer of the application, it's leaving out those top 4 layers, right? And so we could get as far up probably as the second layer. We could tap right in, say, to here. We're still, however, leaving something untested. That's Scott's point. So he wants a test that looks like this. And this could be that thing that people throw over the wall to QA, all right? That's what they do. Okay, well, we've written it the way we think it should work. Now I'm the dev, and I'm going to throw it over to you, and you can click record it. In fact, we have a tool for that. The click record tool for that is called Coded UI in Visual Studio, right? And so Coded UI is a way to do click record playback style graphical testing. It's kind of ugly, as we all know, because it gets brittle up there. There's a lot of garbage up there on top. People climb up to the top of that mountain and leave trash. And that's what's in those views. That's what's in the GUIs up there. So those of us who didn't raise our hands a few minutes ago, we still want to be able to do this in a test-first manner. Even though I know I've got to touch on the skin, I want to do it in a test-first manner. There are tools out there that let us do that that are not record playback tools, and here's one. This is Watton. If some people, I'm sure, here have used it. It is a testing tool for running tests against a website. What we're going to do here is go search Google for me. That's what we're going to do. And I simply want to test that we're able to go out there and hit that web page and we get some expected results back. So to do this, the first thing I'm going to do is take advantage of something called a page pattern that Watton has built in natively in its last version, which is pretty cool. This page pattern essentially lets me represent elements of my HTML page as properties, addressable objects hanging off of my custom type here, the Google front page. So I've got a property, and called search box. And that search box property is a text field type. That's from the Watton API. And what I do is I get the document that Watton currently has hold of. I find the HTML element, which is this text field, and return it back out. So this gives me the ability to touch pieces of that page in a very structured and disciplined way. And I like that because when I go to use the page and write my test, it ends up looking like this. Let's see here. So I'm going to new up that page, and I've got it. And the next thing I might need to do is in the search box, type some text. And this is all that Watton API that I've included here. This is nothing but a DLL that's being added to my test project here. Note I'm using XUnit. This is just a standard unit test. So I'm going to search for this guy. And then I'm going to click and wait for Visual Studio to catch up with me a little bit here. I don't know what happened there. And we're frozen. Excellent. This is not going well. Okay, there we go. Ah, we're back. Okay, so we're going to click that Go button. That's actually our act. If you think about this in the classic arrange, act, assert type model. And what we might want to assert after that is that the page, or I believe it's actually the browser, contains the text. What? What would I have coming back in search results if I Google for David Starr, do you think?
Scrum.
Scrum or elegant code, right?
Elegant code, yeah.
I wish.
Maybe even unit testing.
Here's what I get back.
NASCAR. You guys all know what NASCAR is, right? NASCAR is really popular over here, I heard.
Turns out I will never get Google Juice because of this dude. This guy is a NASCAR truck driver. Ugh.
NASCAR truck?
Yes.
Really?
Yes. All right, I'm going to run it. Let's see what happens. So our test is running over here.
I live in the States, and I've heard of NASCAR. I didn't know they drove trucks as well.
Yeah, it's the Bush League. Bush to the Bush League. Okay, our test is running here. If we watch down there at the Internet Explorer icon on my taskbar, it's flashing. Ha, lovely. Something didn't pick up. So notice that the test failed. Now, I'm going to make it pass, but watch this icon down here on my taskbar, because what it's doing is it's actually newing up a browser instance and it's playing with it, right? I can do this inside Firefox too. Watton at this time does not have Chrome support. Let's see what failed here. Let me make sure that I have all the right things in my code here. Contains, that's it. This actually happened the last time I ran it too. There was just a stateful problem here. I'm going to run it again, see what happens, and if it does not pass this time, we're going to move on. Yeah, I don't know what's going on.
I know why.
You do? Mm-hmm. Tell me. You really think NASCAR's not there?
I think when you run Google in Norway, NASCAR's not there. Or sorry, in Holland. Sorry, I was in Norway a little while ago. When you run Google in Holland.
I didn't make that big a mistake.
Sorry. When you run Google in Europe, NASCAR is not there.
Well, apparently elegant code
popular
isn't
Scrum
either.
guy who's there. There's a picture of some guy in a race car thing.
Okay. At any rate, this is the deal. I can get a hold of that page and I can touch the skin. This is how I touch the skin in the web. The web's a pretty easy thing to do. There are a lot of frameworks out there. Many of them are open source, and Watton is one of those. I'm going to move over to... You really want that to pass?
Yes. I don't like failing tests.
I don't either. We'll let Peter's attempt go here one time, and then we'll move on.
I think motorsports will pass. We have to wait for that browser to pop up, right?
Of course, these things were all passing in the speakers lounge 20 minutes ago.
Of
course, that's how it goes. Okay.
Lose.
It is what it is. So here's what we're going to do instead. I want you to remember this. Go play with Watton. There's some other tools, Selenium. You can get a hold of the top level of your app. You can get a hold of the skin. Web apps are easy. Now, there are other ways to get a hold of things that are richer client applications like XAML-based applications. This kind of gets hairy sometimes. Coded UI, which is something we mentioned earlier, can test these types of applications very, very well. But remember, it's a record playback thing, and what we'd really like to do here is we'd like to go code first. So I'm going to run my little app here. This is a little WPF application. It's very simple. I've got a button and a little label, and every time I hit the button, the label simply increases by 1. About as simple as you can get. All I want to show here is that we can get a hold of that button and we can get a hold of that UI element of the label without any extra add-on, I had to go buy this craziness.
Straight up from code.
Straight up from code. And the way we do that is down here. So we've got some code that will, so I'm going to copy some of this so you guys don't have to live through my lovely typing. There we go. I'm going to clean this up just a little bit. I actually was trying to slow it down a bit earlier to make it so that I could see what was happening. Okay, so what are we doing here? We are taking advantage of something called the Windows Automation Toolkit, or Accessibility API, sorry. Windows Accessibility API. The Windows Accessibility API is that tool inside Windows that if you've ever written code for accessibility for folks with handicaps, you've probably touched this API. So for example, if someone is deaf, blind, etc., there are features in there that let Windows behave, or your application behave a little bit differently in Windows. And one of the ways it does that is it can shim or put a layer, this is how I like to think about it, it puts a layer right in front of your app, thin sheet of glass. That thin sheet of glass becomes programmatically accessible and it knows how to grab the things right under it. So that is our window. So I'm actually newing up our window here. And then from that toolkit or that API, I get a window peer. That's my little sheen of glass over the top of my application window. From that, I'm going to get the children that are on that window. These are the controls, and I have to go find them. And you can tell by the fact that I'm looking at array positioning there that I had to probably run this in debug mode a few times to figure out where I was on this form, and that's true. So is this still fragile? What's going to happen when I go drop another button on this form? It may break. This type of thing is not awesome for that. Okay, so we've got all of these things. Now what I want to do is assert at least that we've got a 0 in that text box. So before we act upon it, before we push the button, I want to know that there's a 0 in that text box. So there it is. And then I want to click the button and finish out my test. So we're going to click that button. We'll look at what this code does. And then we get to assert that the label actually went to 1. And then I'll kill that thread sleep, and it just closes the window out. So news up the window, gets a hold of the children, grabs the right children, clicks the button, sends out event args to that, and then makes sure that the label responded. The clicking button piece, just have that in a little method down here. It's pretty simple. I get a hold of that button as a button, and then I create the event args that would go into that click event and pass those in by actually raising that event. So I'm just raising the event. All right. So this is the one, push the button, that I want to see pass this time. And I'm watching my little green bar expectantly. You know, I realized the other day that after having done TDD and things like this for so many years, it still gives me that little fist pump feeling when things turn green like that. So there is a way to get a hold of the UI for people like Scott who really want to do so.
So have any of you ever accidentally hit the Shift key on Windows 5 times? So when you do that, it pops up the thing and it says sticky keys, right? Sticky keys is the built-in reader software for the accessibility, and it is sitting on top of this exact same API. So that gives you a sense of what this API is really for those accessibility readers. But wow, what a cool way to reuse that API for something else, to think about how we can leverage that exact same capability to get in and test at the top.
You do end up having to create your own assertion models for things because it's not a framework meant to be a testing framework, right? And with Watton, we were able, for example, to say, my browser contains some text, and that's an assertion. We don't have that here. We have to roll our own logic around what it is we're doing because the API obviously was not meant for testing.
Right. All right, very cool. So there's been a few interesting things. So Dave, I went kind of in at the bottom, and David went in at the top, and I'm going to take us back down nearer to the bottom again. I mentioned all of these patterns when I was talking about that ASPX page. And in the ASPX page in particular, we were using the pattern at the top left, model view presenter. All of these patterns, you can see they share a common structure, right, of this separation of concerns between three important things. The view that the user interacts with, some model data that is what your application is actually interacting with, and then some sort of a mediator or moderator who coordinates between the two. And really the biggest difference between them is kind of the direction and number of arrows. Right? In MVP and MVC, they kind of cycle around, and in MVVM, they kind of slide across. Because, in fact, in MVVM, the view model has also got a little bit of controller presenter in them as well. Now,
so just for fun, Peter, I'm going to highlight the ones where all my business logic goes, right?
Not necessarily.
Really? Because that's what I find when I open the code.
Yeah, we do often find that people like to put their business logic in these classes. I'm not a huge fan of putting business logic in here. I'm a fan of putting presentation logic in here. I would always rather keep my business logic in separated and distinct business controllers or business components. I like to have every class do one thing and do it well. And when we talk about a presenter, his job is presenting the model. And a controller is responsible for coordinating the presentation of views and models. MVVM has got the same thing. It is certainly easy for us to kind of cheat and fall back and drop some code inside there. And in fact, I think I did that in mine. And when I said I sure would like to have refactored that out, that's exactly why I wanted to do that refactoring, because I had put business logic inside of my presenter. As we continue to think about these APIs and designing them, we start to want to really pay attention to how we make these separations occur. We want to always try to think about these classes as being separate and distinct entities. And these are going to allow us to make sure that we can test a thing and know exactly what it is we're testing. Now, I showed you an ASPX page using an MVP, and I also showed you an ASP.NET MVC, which used that MVC pattern. I want to show you one other one. And this is the newest in the family in ASP.NET. And this is the API controller. This is for the web API stuff. And this one has had, like we mentioned earlier when we showed the workflow context, about that evolution in time towards better testability and towards a better usability and separation of concerns and cohesion. This is the one that's had the longest life. And so what we're going to find is that, in fact, it's actually the cleanest for us to work with. So when we build a web API controller using MVC, what we're really building is a REST endpoint that is typically going to be consumed by a JavaScript web page, right? And all of the mess of making that work has been taken care of, and we can focus on building just what we care about, which is the endpoints of the service. So when we take a look here, we see I have get all products, and it's going to respond to this HTTP message, get on that URL. And I have a single product, it's going to respond on this one, etc. And here I can now even do with parameters. And all of these are simply reaching into the repository to get stuff out. And in fact, my business logic isn't here. What these are is really just queryers, query accessors for reaching in and getting in and out data. Because there isn't really a lot of business logic going on in this particular service. But I wouldn't want to put it here. This should always be about just interpreting model data for presentation at the JavaScript layer. Testing this is easy, like we want it to be. We don't want to see me having to use a lot of shims and a lot of stubs, but let me show you what I ended up doing while testing this. So, as David did, I'm using xunit.net, which is just a different testing framework. I'm going to be mixing and matching throughout the day. Again, I'm following a simple arrange act assert pattern. And I'm very easily able, with just a few lines of code, to new up that controller. I don't have to mess around with contexts or anything else, and make calls on its methods, knowing that the JSON Web API stuff is handled for me, and that I don't need to test that. I don't need to confirm that ASP.NET MVC does what it's supposed to do. I do want to confirm that the code I wrote does what I expect it to do, and that I'll get back the object types I expect. So I can push things into the repository, I can query on them using the various APIs, and I can get back the data. Again, I am using a mock or a stub for the repository because I did another separation of concerns by pulling out that data model construct, the repository pattern, out of the controller. Don't want to have that be baked right in. Of course, I could have. I've certainly seen plenty of people do that. And when you do that, then we have the problem of we have too much stuff in one place and we can't test it. Sorry. Excuse me. So the interesting thing as I was testing this, though, and I've already delivered some of this feedback back into the MVC team, is I ran into, when you're doing a REST API in MVC, and you do the post handler. So in REST, get is the retrieve operation, put is a save or an update operation, but post is create a new one. So it means you didn't know what its ID was, you didn't know what its canonical URL was. And so if we look at how I had to implement, and I followed the patterns recommended by the ASP.NET team, you can see this method on line 43 returns HTTP response message. And it uses this request.createResponse to do so. And unfortunately, this took me back into that same land of the ugly context. It's a little bit better. It was, and I'll show you how I tested this. Because if you're going to be building these web APIs using MVC4, you will run into this. So if we go down here and look at my post tests, I did some work, spent some time with some people on the MVC team to figure this out. And I have already posted this snippet of code up onto my blog for anybody who's building these kinds of systems. You can get the sample, the little helper method that I have here. And the helper method is here on line 179. Because it turns out that I built up this controller, and if I comment out this line and try to run this test, you can see that it fails. And we get an argument null exception, because it turns out that line of code that we had back over inside of the post handler, which said, you know, response.create or request.createResponse, request is null. None of the context exists. So I worked very closely with a couple of guys on the ASP.NET team and figured out how to fix it, and we found this wonderful little helper method. And it's oh so nice, but at least I didn't actually have to do a whole bunch of ugly shimming. We just had to figure out all of the various configuration glop that we had to assemble to make this happen. And as I said, this snippet of code is a snippet that I have posted, so when you get to building these kinds of systems, please feel free to reuse it. But basically, we discovered we had to create the configuration. We then had to define its routing structures, because, of course, MVC is all about routing. That's how the get gets automatically mapped into your method call. We then had to hook it all up inside of a controller context. We had to stick a request inside of it. And once we got all that built up, now I was able to make the calls I needed to make. So here's a little snippet for you. And again, an example of why you want to think carefully when you're putting these APIs together. They built this wonderful little helper method for us. Request.createResponse. It looks so nice and so easy to code against. But it's not fun to test against. And so when you're building your APIs, be thinking about that when you run into these APIs. We've got little tricks for getting around them.
If that is the cost of not configuring WCF, I'm good.
Yeah, that's true. I mean, that's true. I mean, admittedly, this is certainly much better than doing WCF unit testing, because if you've tried that, that's not pleasant. These REST APIs are always going to be much easier to test against, and the controller structure makes it even better.
Okay, so you're picking up on a theme. I'm sure by now we can see that the essence, heart, and soul of testing really comes down to teasing things apart and then testing those things that we've been able to isolate from each other. So if we think, for example, about an object graph, few objects, we've got one thing that we're actually interested in this object graph, that these things all talk to each other. This might be it. Okay, so we're interested in the number 1 class here. And so what we do is we surround it with fake or dummy or double, whatever your term is, classes that aren't real, right? They're instantiated inside the test project typically. The reason we do this is because sometimes the way to test what 1 is doing is to check the behavior of 8. And sometimes we learn that that's not what we expected to happen. That gets us into mocking. So we're going to jump over to some code here, and there are some interesting things about this tiny little method of code. One thing is that, let's just go through what it is we're building here, because I've switched projects on us. We've got some specifications being created for a class called the class being created, and we are creating a fake parts repository and something else that we're passing in null to the constructor of this class being created. So I'm a developer. I'm doing test-driven development, hopefully. I'm a little bit ahead of my implementation. And I say var system under test equals the new class. And I don't care about this particular argument during this test. Now, this is interesting because I've got a class here that I'm passing some kind of dependency into that I know in certain conditions this class will not care about. That in and of itself should make me start to wonder about smells. Is my class doing too much? Have I split read and write operations well enough? Let's go take a look at this constructor. So here's the constructor that we're calling. This class being created takes an I motor factory and an I parts repository. Just some classes that I made up so that we could talk about the structure of them. I happen to know that when I call the save3things1 method on that class, it's not going to care about the motor factory. So we could probably run this. Let's go ahead and do so. Yeah, no problem. Now this scares me a little bit. One of the things that might be true is that my class being created is high enough up in my API. Maybe it's one that I want to directly expose, say, to the next developer in my life. And what that might mean is that I want to add a guard clause for that null. So I'll do so. I'm going to come over here and add that guard clause for that null. There it is. So now my test hopefully will pass or fail. Yeah? And it did. So this technique that we've been using so far is passing in this guy, which is known as a dummy. He is a type of double known as a dummy. It doesn't do anything. It's really silly and simple. But now what am I supposed to do? Well, now I have to go create some type of representation of that motor factory. And there are a couple of different ways to do this. Certainly I could create a mock. I could implement my own test instance of it. Here, though, is something I would encourage you to start thinking about. And that is to be able to provide in your APIs null object types, null implementations of your interfaces. Because the people who are consuming your APIs often want to touch them in ways that you can't predict. The null object pattern rather, is quite simply an implementation of an interface or abstract base class that provides absolutely no implementation whatsoever. That's it. But they happen to be very, very useful to those who are playing with our APIs. In some cases, they make very valid arguments. I would simply encourage you to look at that and see if it might help you with a few things. Null object pattern. Now this next thing is that I'm creating something called a fake repository. We saw on my constructor for the class being created that this is actually an iParts repository. So an iParts repository, we could get this, again, in a few different ways. If I look over here, there's the interface in my Solution Explorer. I don't know that the folks in the back can see this. The real thing that I want to show you is here's a parts repository class, and that's actually not the system under test. I'm going to go ahead and delete it. So what this means is that I currently have a test that is going to check the class being created, and it does so against the contract of the fake parts repository, and there is no implementation at all in the library that I got from my vendor. So what I've done is created my own. This is another way to create a double, another type of double. This one, there are a couple of different ways to think about it. One is as a fake, another is as a spy, because it does something interesting for us. If we look at the interface of iParts repository, all it requires are these three things. I can save a part, save some parts, or get a part. However, if we go back over to my implementation, which is this guy, he has more functionality. He's got a constructor, get a part, save a part, save a part, but he's got this funny thing down here. It's this property called times method called save something. What that really is a flag. What I'm going to do is, in my fake implementation of that guy, anytime something gets saved, I simply increase that counter. This allows me to spy into the behavior of the system under test class, such that I can come down here and say that on my fake repository, the times the method was called was 1. This type of test is called a behavioral test. It's also referred to in some circles as a mockist test. And look what we've just done. Have we really tested anything? What we've kind of done is we've tested the internal implementation of the system under test. It's definitely a white box test. We are pinning functionality in place. I like to think about these as pinning tests. So I've got a big set of functionality. I just want to pin it up there on the wall so we can all see it forever.
Have you guys heard of the expression pinning test before? Right, the idea is you have a system, you're not really sure about how it works, you need to kind of pin it down onto the table. And so you pin it down with a test, and now you've committed that behavior. Sometimes they're also called characterization tests, but David and I really like the word pin because it's got that metaphorical, it's got that picture in your mind of pinning it to the desk.
So after, oh gosh, I'm just trying to hide that guy out. Things aren't quite adding up when you zoom. Did you notice that in the editor?
Sometimes.
We're getting there. Release candidate.
Release candidate.
Okay, so here we've gone a little different route, essentially tackling the same problem, but this time I'm not rolling my own. This time I'm my own repository, and I'm not using a null motor factory. What I'm doing instead is using a mocking framework. In this case, it's MOQ, or mock. And what we are doing here is simply providing the two dependencies that we have to that constructor with the mocks that we're creating up here. Okay, so MOQ is giving me these fake little guys, and then I can call my system under test yet again. Now, this, though, is the interesting part. If you look at that mock parts repo, we are able to look at that object and use its own internal assertion model, right? So we don't have to write our own assert dot is true, assert dot equals, that sort of thing, because there's an assertion model built into this mocking framework, and that's really the characterizing aspect of mocks. So look at what it does when we run this. I think it'll pass. There we go. Actually, let me jump out here. Save three things pin. Yeah, that one's failing now. here we go. All right. So it passed, and what are we asserting? We are asserting that on our mock repository, there was a call to this method save that took a list of iParts. That's what we're asserting. Now, if we were to change this test, because guess what? To me as the tester, I can't see a big difference here. I want to know that save was called exactly 3 times, passing just 1 iPart. Do I care as the tester which one of these things happens internally to the class? I really don't. However, if I run this, it fails because the internal implement... Awesome. Yeah, they're good.
It was on the green for a second, but that's okay. That's not my test runner. You're using the other guy's test runner.
Oh, that's right. You know what? My bad.
What's my test runner say?
Let's try that again. That's a good point. Yeah, I had ReSharper's test runner up there for a moment. What was I thinking? There we go. Actually, this one is a lot faster.
Thanks. Yeah, there you go.
It is. In fact, okay.
All right.
We got to tell the story. And 2 weeks ago, Peter and I were prepping for this talk, and we were going to try and tell you guys that it's a really bad idea to have thousands and thousands of unit tests in a single test project. And so you ended up creating...
I have it here. If we have time at the end, I'll run it.
No, we won't. We ended up creating a Visual Studio project that had a real representative system under test with a real representative set of unit tests, 36,000 unit tests?
I think it was 24,500 by the time I was done.
24,500. We couldn't get it to slow down.
No. I was trying to demonstrate that there was some problems with how you can organize your tests in terms of performance, and it just kept running too fast. So we decided to take that out of the demo.
You can apparently do this however you want now. Okay. My point and the takeaway on this little bit of code is simply that I don't want to be asserting against my known internal implementation of those classes. That's just yucky to the core, and I want to try and stay out of that. Okay? I'm going to jump ahead to another type of test here. This time we're using something called an auto mocker. Anybody use an auto mocker? Okay. Well, Peter and I are going to have an argument about it in a minute, so we'll see if you want to try it or not. An auto mocker is this thing. It's this thing that wraps up that mocking framework for me that lets me not have to actually declare all my dependencies. So remember that my class being created, that guy, he takes 2 dependencies on his constructor, right? Okay. I'm not clearly using that here.
So this guy news that up and automatically fills in all the dependencies.
Exactly. So
if it took 30 interfaces on his constructor, it would still do all that for me.
Well, we'll see in a second if it'll do that for me. But for right now, I know that I'm not passing any sort of constructor parms. So let's run it.
See, this is why you keep running the other runner.
Here, I'll just turn that off. Gotcha. It's going, there we go, 4. Number 4, it passed. Okay, so this guy passed. So what he's saying essentially is, yeah, I knew that thing up for you. It had all of its dependencies, and apparently everything went fine when you made the call. Now what's kind of interesting is, what if I go in here, as Peter was talking about, and I go into this constructor of my type, my system under test type, and I do this. I say, not only do I want to get those as arguments, but I've got another interface. I want one of those. Okay. And I want one of these. And I'm going to need in my constructor, because obviously I've not yet got enough constructor arguments, an int. What's going to happen now? Well, I'm going to go do my build. It's just a build. And oh darn, I can't build. Well, why not? Because I've got 2 tests over here that are passing the wrong constructor args.
So these are the ones you did without the auto mocker.
That's
the ones
right.
without the auto mocker are now struggling because we've added new constructor parameters.
Exactly.
Okay.
So this happens all the time. I go change the external interface or whatever of my class that I'm working on. I have to go back. I spend 30 minutes refitting the tests that used to work to the new contract of the external interface.
So have you ever, as a developer, had to say to your product owner or stakeholders, yes, we can do that, but it's going to be really hard to fix the tests? Yeah. As a product owner, I hate hearing that answer.
So I've commented out the 2 tests that didn't compile. I've left the one that uses AutoMocker, and because I've got this little button checked over here, hopefully you guys know what this little button is. Do it this way. That little button, if it's pressed, means that every time I Control-Shift-B build, I'm also going to run my test. So let's do that. And the name of the test is _4, so we should see it pass, and it does. Or is it still? Oh my goodness, it didn't.
What's he unhappy about?
Well, yeah, I don't know.
Unity. Your Unity failed.
Good Lord, I don't even know where to go for that right now. Here is a suspicion I have, though. Let's see if I'm right.
Nope.
Nope. Well, this...
Take the engine string out.
Yeah, this stinks.
Take those guys out.
All right, well, the whole point there was sort of defeated in the demo, wasn't it? I apologize for that. I don't know why that happened. What's going on with the AutoMocker is that it has to resolve all of those dependencies, and typically it knows how to do that through an IOC system of some type.
The idea of these AutoMockers, then, is to save you the need to maintain the test suite as you adjust the parameters that are required. Because if you're saying that you really don't care and you're happy to have a default, a replacement stub, a replacement mock, it's all good to go. The concern I have with it, and this is the thing I started to poke on just a second ago, is it allows you to fall into a design pattern that David and I have started calling a dependency addict. Right? Is that the word?
Dependency addict.
Dependency addiction. And if you start to find yourself wanting to create a class that wants 5, 6, 7, 8, 9, how far do we want to go interfaces? That can't be a good thing. It's far too many dependencies. We start to get very coupled to everybody else around us, even when we're doing it through an interface. Yes, we're nicely separated via the interface, but wow, we certainly have a lot of dependencies. And that starts to make me have the kinds of concerns that we're doing too many things at one time. And that's why the AutoMock worries me, because in fact, I like the pain. The pain of having to deal with the fact that every time I change the constructor, I have to go back and change my test, reminds me to be very sensitive to just adding arbitrary dependencies.
I think this is a very valid point, and unfortunately it's not very well demonstrated with the fact that that didn't behave negatively for you. One thing that I do want to mention before we're done with this piece is simply that I can use this AutoMocker, the mocks that are created by that AutoMocker, the same way I used mocks before. That is, I can set up expectations on them. I can have them return things to my system under test before I invoke the system under test that was created with that AutoMocker. So that is test 5 there, and that works. What this shows us is that not only can we use the auto-mocking technique to fake out all of those dependencies, but that we can prescribe behavior to them. And it has an assertion model built in because it's using MOQ. It's just mock. It's just MOQ. These exist for Rhino, and they exist for all of the other mocking frameworks.
Yes, they do.
Okay. Dandy.
All right, well, I'm going to click over here real quick because I want to say, and somebody wrote one for Visual Studio 2012 fakes, too. You can get it off Codeplex. And it does exactly what David was just showing you. So you can see doing the same thing. Auto stub, get the types, and all is well. All right. Let's move off in a different direction for just a minute. And this is a common question that comes up when I'm talking to people about unit testing. It sounds like a simple question, but sometimes it can be problematic, and sometimes there's very good reasons to have to do it. But people say, how do we test events? What's a good pattern for testing events or classes that raise events? So there's a bunch of things we might want to test about an event.
Well, these are questions you might have.
Yeah. So when we're looking at this class, did the event get raised at all? That's a good one. What was the last event that was erased? How might we know about that? You're popping up things on the screen.
Oh, geez, sorry. I thought it was...
Did the sender send the right argument data? And then did the event handler behave correctly? These are all interesting things. So the handler side, of course, the subscriber to the event. That's an interesting problem. And then the first three are about the sender of the event. So let's take a look at then some code. You can alt-tab all you want now.
I can go back and try and make it run still.
I think it was the int and the string. OK. So here we have a very simple class. And I'll show you a little bit more complicated one in just a moment. This is a simple class that has a method called doSomeWork on line 23. I pass in a value. It manipulates that value into a new value, and then raises the event using the standard, protected void event raiser function. Now, what I really need to be able to test here, if we look at the code that is my code, the code that I'm going to want to confirm and pin down with a test, it's this block of code right here. This is what I need to be able to lock in. This is the little bit of logic that I might want to be concerned about. So how am I going to do that in a test? So I'm going to start off in a typical arrange act assert structure. I'm going to new up the class. I'm going to call the method. And now I say, OK, what do I do now? So we know from looking at the code that doSomeWork called that event for us, but we didn't have a way of getting it. So let me show you my favorite way of dealing with this problem. So if we say SUT dot, and you can see that my event shows up here in the list. It's an event, which means it's a delegate, and I can now take advantage of closures and Lambda expressions to make this very easy and terse and easy to read test. So I'm just going to do this. We know that an event handler takes the sender and the event args. And now I have this nice little place I can put some code. And what I want to confirm in this one is that the string I get back is the string I expected. So we need to get the value out of those args. So that's E dot plus equals. So now when I look in the event args, I can see the custom data that's coming along inside of here. I'm going to go ahead and collect that. And I'm going to take advantage of C# closers to store it. So I'll call it received data. Now I need to put that somewhere. And I'm going to declare it outside the scope of the handler. All right? So now I've collected that data up. I now have something I can assert on. And it's a strange looking thing because the declaration of the collector happens before, but it all works just fine. So now I should be able to assert that the string is hello Amsterdam. What did we get back? Oh, looks like I have an extra. What are we saying here? Comma. OK. So this is now the general pattern that I use when I have to test around events. It's a simple pattern. The tests are reasonably easy to read. It's all in one place. These are things I like to find in my unit tests. If I had used the, you know how when you do an event handler and you go plus equals and you hit the tab and Visual Studio writes a bunch of stuff, that would have ended up in a method further down in my class. And now when I'm reading that test, I would have had to scroll around to find it. This is a case where I really find the Lambda syntax is a very valuable way because it keeps it all in one place and it lets me leverage the closure. If I'd had to put that as another method, I would have then had to introduce state into my test class itself, which has all kinds of problems on its own. Now, there are cases where this is significantly valuable, where eventing is really an important part of what we're doing. This is a simple, contrived example. But you may have run into out there the pattern called event asynchronous. So this was the most common way of doing asynchronous programming in .NET prior to .NET 4.5 when we got the task parallels library baked in. And when you find that, so here's a class that is a prime number calculator. The way these are typically consumed is you set them up and you say, calculate async. So there's the do method that's going to do some work. And the answers come back on event returns. And it spins off background threads. You can see he's spinning up an asynchronous operation and doing some state locking and all this other stuff to make sure that he stays stable. And then he raises these various events. And here are the events that I'm going to get down here at the bottom. Way down here at the bottom. All right? So what we want to test, if we want to test this method, we want to test this prime number calculator, we have to have a way of dealing with testing against events. So it's a business logic thing we're testing, but because of its async multi-threaded nature, we have to do that. So let's look at how we can test that guy. Right? So here's our event-based test. So I'm going to new up the prime number calculator. And the way the calculate prime completed event works is it returns back a Boolean that says whether or not the number you asked for is prime. And so you can see on line 18 then, I do that exact same trick of the closure to collect the result. On line 19 then, I do the wait handle. And the reason I need the wait handle is because this is an asynchronous operation. And since it's an asynchronous operation, I have to make sure that my unit test doesn't just run all the way to the end, because it will. And so I use that wait handle on line 26 to say, hold on, stay here until the event fires. Okay? And then inside of that lambda expression, and I'll break this into two lines so you can read it easier, I do two things. The first thing I do, I collect the data value out, which is the one I want to test against, and then I set the handle, which says, okay, now the test is allowed to continue on. So it's just a little semaphore trick. And that is all I had to do to test this guy. And if we take a look at the event-based test then, right there, we can see it passed. You can also see it's really fast. 3 milliseconds is great. Now, if you're using .NET 4.5 and you want to start to shrink this down a little bit, you can actually wrap it all up into a task. And now I don't have to deal with that semaphore, that wait handle anymore, because the task takes care of it for you. And task already has built in the capability of consuming event-based asynchronous work. So this shows you just a little hint of async and of events and of why unit testing events actually is important. Because I have heard people say, oh, you don't need to test events. Yes, you do. So there are a lot of interesting patterns for multi-threading, and I just hit on a couple of them there. The oldest one in .NET is called APM, the Asynchronous Programming Model. You've probably seen that one. And then the second one which came along was EAP, Event Asynchronous Programming, and that's the one I just showed you with the prime number calculator. And then I showed you how the task parallels library can be used to wrap up EAP with the task completion source. But in fact, the task parallels library that we now have in .NET 4.5 makes all async things better. Anytime you're dealing with whether it's old async or new async, the task parallels library is going to make it a heck of a lot easier to deal with, because we now get the opportunity to use asynchronous tests, because both MSTest and XUnit.NET support asynchronous testing. So when you're testing against async, which is a common problem these days, you get to take advantage of that. Now, to show you really quick one other version of this, and then I'm going to move us on. So this was my test against the event one. And you can see I used that task completion source. And basically, I just attached him up to the same event that I was testing before, that calculate prime completed. And by attaching it up to the TCS, I now have a task. And because it's a task, I can await. And await is the wonderful keyword that makes all of this wonderful async programming simple and clean and read straight through. But that other pattern, the APM pattern, also has its interesting problems. You have, in APM, you're typically going to have the begin and the end, right, where you call begin and then you call end and one of them blocks, weird things like that. Well, it turns out you can wrap these up with the new task model stuff as well. And when you do that, it's as simple as line 29, where what we have is from async, a simple method. You give him the begin, you give him the end, you give him the arguments, turns it into a task for you, and now it's very, very easy to unit test. So if you're ever dealing with any async code and you have to test it, I really strongly recommend you go to take a strong look at the task-based stuff in .NET 4.5, because it's going to make it easier to test. The patterns are going to be a lot easier to go with. You're on.
I know. And what I wanted to show is that it works.
It was the string and the int, wasn't it?
It was. So I pulled those primitives off of there. We're doing strictly contract-based with interfaces. And there's the right monitor. And
yes.
We're passing.
Yeah, so I suspected when I saw the Unity error, the problem was Unity didn't know what default value to provide for string and for int. You actually can configure Unity to do it, but I'm guessing that by default it was not. So
you have to provide your own container implementation
yes,
to
you
do
do.
it.
Yes, you do, and then we would have been good. All right, so we were able to make that one pass. Excellent. All right, so we're back over here. Let's click. No, click.
Yeah, I'm getting there. Okay. You would think. Here we are. So we went through events and threads, and real quickly we wanted to talk a little bit about packaging patterns. We told you guys that we tried really hard to break the new unit test runner so that we could make a couple of assertions here. And instead of doing that, we are going to not talk so much about the timing stuff, but about the advantages, disadvantages to how you package your tests. One thing that I wanted to draw attention to one more time is this run tests after build option. This is that little button that I had clicked that said every time you build, run. And in a world like that, you suddenly change how you start thinking about packaging your tests, your developer tests in particular, alongside your system DLLs, or your system under test DLLs. I have seen this pattern a lot. We decided to call it the playa, because the playa goes out with everybody without telling anybody else that he's going out, right? Non-exclusive relationships here.
It's a harem. We should have called it the harem.
So people will build a big Visual Studio solution, and inside that solution they'll have a test project, one. And they'll use namespaces inside that thing to break out the different test structures that now point to various solution or projects in that solution. Because we know we should create a DLL here, a DLL here, website here, whatever, what have you. Then we have one unit testing project in there, and that's what this looks like, the player. Do you have problems with this?
I'll tell you, there's a few things I don't like about this. First of all, is the reason we split these things into assemblies is potentially so we can reuse them. Right? Why not just put the right side all in one assembly? Right? We obviously have a desire for some reusability here, or we wouldn't have done that. And yet now if I was to give David assembly B, I can't also give the tests. And I don't like that at all. I want to be able to give the tests. I want to think of them as a unit as I give them to other people.
I think of it as a config management issue myself.
That one as well.
If you give me something for me to consume as a shared assembly, I want to see those tests come along with it. I can't do that here. This is a pattern we call snake eyes, because you end up with two test assemblies per system under test assembly, often creating a set of unit tests and a set of integration tests to go alongside each assembly. What's weird about this one, however, is that you're probably not needing to unit test, or rather integration test, assembly A. What makes more sense is to drill down from the top and test all of those things in a single integration test that's defined and structured around business functionality. And so the way we do that looks like this. We have maybe a little bit of integration test down there in test project 3, and we have a little bit down in test project 4, maybe a little integration testing. However, our primary integration tests are packaged and organized up to into the functional test project that is a special project dedicated just to that. And maybe if we're talking about a website, this is where my shopping cart tests go. And this is where all of my administration tests go, and this is where all of my other business functionality tests go. And that makes sense because we can separate those two from the continuous integration build.
And I'll tell you, I like this one a lot more. It allows me to take the rows and share them, and it acknowledges that the vertical columns are about testing my application. top to bottom in various ways: functional, performance, security, and any of the other kinds of tests I find interesting. This is my favorite pattern for organizing your tests, and it's really not that hard to set up. So if people tell you it's too hard or too expensive, we're only talking about a few extra projects here, and it's got a lot of payout in the long run. All right, so I want to just thank everybody for coming out and listening to David and I talk about this. We've discussed when we were first putting this talk together that we could probably go for 3 hours on interesting and crazy and difficult things in developer testing. We picked out a bunch that we have been hearing from a lot of customers and talking to people at the booth here and in Orlando and in our travels around the world. Hopefully you found it useful. Here's our contact information. We will also be hanging out down at the booth for parts of today and for tomorrow. And I hope you have a great rest of your TechEd. Thank you, David.
Thank you all very much. Please remember to do your evals.